Now we're going to take a look at the electromagnetic spectrum diagram, which is found on page 14 of your Earth Science Reference Table. Now, the electromagnetic spectrum diagram arranges many different kinds of electromagnetic energy in order of wavelength. Remember that electromagnetic energy is energy that travels in waves through empty space. So, a distinguishing characteristic of the different types of electromagnetic energy is its wavelength. Now, we see some different kinds listed here. For example, all the way to the left-hand side of the diagram, gamma rays, X-rays, ultraviolet, visible light, infrared, microwaves, and all the way to the right-hand side, radio waves. All right. Now, as I went through and named the different kinds of energy, you may say, where did this visible light kind of come into play? Because it's not up in the array that we saw with gamma rays all the way through radio waves. Well, it actually is, because visible light is a slice that kind of fits in wavelength size between ultraviolet and infrared. It's just that for us, in our study of earth science, visible light energy is so important that we need to not just know that category, but also be able to break it out into the different colors of the visible light spectrum. And that's what this does. So the visible light spectrum actually shows us everything, again in order of wavelength, from violet to blue to green to yellow to orange to red. Right? But remember, that all fits right in there between ultraviolet and infrared. Now, if I'm saying that wavelength is oh so important here, we need a key to wavelength on this diagram, and we have it. If you look at the label all the way here to the left-hand side that says decreasing wavelength, decreasing as you move to the left-hand side. Decreasing wavelength then would mean, of course, that that would be the shorter wave. What does a shorter wavelength look like? How might it be represented? It would be one of these really, really tight squiggles. Think about the slinky that's all compressed. As you move to the right-hand side of the diagram, then, we see the label that says increasing wavelength. The more you move to the right, the longer that wavelength is. So then, we have this longer wave end of the spectrum, and that would be represented as a kind of stretched out wave, almost like that slinky that is pulled to its full length. Now, one other comparison that we can make between the shorter and longer wavelength ends of this spectrum is in terms of the amount of danger, exposure to those kinds of energy presents. Clearly, as you look at some of these names, you see all the way to the shorter wavelength end, gamma rays, X-rays, you do not want exposure, or at least very limited exposure, to any of those, like medical X-rays. So this is the more dangerous end of the spectrum. Whereas as you move to the right-hand side, microwaves, radio waves, we even have appliances that emit this kind of energy in our homes, so they are clearly the less dangerous forms of energy. Now, if you were to say, all right, now what kind of questions might I be asked about this diagram? Well, let's take a look. For example, which form of electromagnetic energy has the longest wavelength? Well, okay, you look for longer wavelength. Remember we said that's going to place us over here, right, towards the right-hand side of our diagram. So you're simply going to check the positions of each of those different choices ultraviolet, visible light, gamma rays, radio waves. Here we go, all the way to that right-hand side. You better believe that is your right answer. Let's take a look at another. Which color of the visible spectrum has the shortest wavelength? Well, now we're in the visible light spectrum. Okay, remember, we're going to be in this particular slice right here. And again, it's arranged in order of wavelength. So I want the shortest wave. Again, I'm looking to see, okay, shorter. This is going to be to the left-hand side of my diagram. Shortest wavelength, well, here's violet, blue, yellow, and red. Okay, which one's shortest? Gotta be the violet. Okay? So when you examine this electromagnetic spectrum, just be careful that you keep in mind the positions of the different wavelengths, and you'll be in good shape.